we look at another type. We call it the symmetric matrix. I have already told you about the operation for transpose. Means either write it this way, a prime, or here, means you're going to switch the row to column and the column to row. Let's look at special matrix. Talk about the distances between three different cities, A, B, and C. And the city between itself, of course, is 0. The distance from A to B, let's say, is 100 miles. Then, of course, the distance from B to A is also 100 miles. And the distance from C to A, let's say, is 150 miles. And then from A to C is also 150 miles. And let's say the distance from B to C is 200 miles. So it's C to B, 200 miles. See what is special? And this matrix, you can do the transpose. That means after you change the row to the column, what's happening? Let me change the color. Nothing happened. It's exactly the same. The first row is the same as the first column. If you swap it, it's still this. The second row is the second column. If you change it, it is still the same. And so is this. Now last row is the last column. You get a 200 and the 0. So what I mean is the transpose equate itself. That we call it symmetric matrix. Symmetric means the row and the column are exactly the same. Well, the last special type I want to give is this. If let the B matrix stand for the score between three support teams, X, Y, and Z. We read from this way. And the first one, we don't compete with ourselves. That's all 0. If the team win a game, got 2 points, had the draw of a game, each team earn 1 point. The team lose the game, lost 2 points. So look at the matrix. This one means the team X against the team Y. X win, you read from the row, and the X get 2 points. And then you look at this, Y against X, the Y lose. So what he got? Negative 2 points. And Z and X, the X lose, Z win, X got a negative 2, and then Z get a 2. All right? And if the Y and the Z had the tie, and they both got 1 point. So obviously, this is not going to be symmetric. It's absolutely not symmetric. But if I remove this draw, let's say the game happens to be either win or lose. And then in this time, I assume the Y team lose. And the Z team win. And then Z got 2 points, Y got a negative 2 points. That's another special type of a matrix. And if you swap the row and the column, what's going to happen? You're going to check. B, if you transpose, means the first row became the first column, second row became the second column, third row became the third column. What's happening? The B transpose equals negative of the B. And that we give a name, again, called anti-symmetric. That's our example. Oh, that's only 3 teams to save time. Okay, we got a few concepts: identical matrices, diagonal matrices, symmetric matrices, anti-symmetric matrices. In the next 10 minutes, we are going to learn how to write the equations into matrix form. And we know the dot product. And now let's look at this example. Talk about the Hawaii green sea turtles. The novice breed, again, 280, mature breed 70. And the total of the eggs equals the dot product. We checked this before. But if I'm the scientist, all I found is the number of eggs. But I really don't know the number of breeders. How many are laid by the novice breeder? How many laid by the mature breed? All I see is the eggs. Then I assume their number, I don't know. Here, I don't know this, I don't know that. I call it M and N. And then the total number I know, which is, I forget the number, but let's say it's 1,000 something. Instead of putting numbers here, I just put the variables here. So what? It's still dot product. 200 times M, that's the eggs laid by the novice breeder. And 70 times M, that's the total number laid by the mature breeders. Let's assume the total number. Let me do an estimate. Let's say it's 12,300, something like that. So you get an equation. That's all you have. And you may get another observation. In some other location, you know, maybe let me think about it. Well, you can get another equation. If you want to solve the M and N, you know you need the 2 equations. And then you can say next year, maybe this, or next month, I found that the total laid by this much eggs, this many eggs, but the egg of the novice breed still do the same number, around the average 280, mature 70. Then you could get a, maybe next month, this number is a bit different because the age. The next year, the novice become mature and the later 70, and then you have 70N, and the mature still mature, but you got the new eggs, maybe matured as novice novice breeder 280 times M, and you got another equation. Then you got a system equation. I did not think through this. But that's the idea. We got the equations. Let's look at the last example. So we use the dot product translate the one side of linear equation into the matrix form. In this example, I can rewrite as a dot product, and E is the number of eggs laid by the two. B is the number of two different breeders equals A. That's a number. Basically, it's better to write it down this way. Distinguish the number and the vectors. And we can do the same way as 2, 3 variables, 2 to 3 equations. Let's just look at an example to finish that. Let x, y stand for the percentage of the WTS and the BTS with relations. And then use the H vector as the x, y. And the total sharks in the 6 months, again, is this same vector. So if I want to think about the total number of sharks with relation in the first month, that's the equation. Instead of giving the total number of relations, the percentage, I give x and y. And then that get the first month. If I write into dot product, I write 20 and 15 dot, no, this way. 20, 15 is in a row, and the x, y is a column equal 9. And if I need to look at the second month, okay, you get another equation. It's 6.57, 527 times x, y. What is the number? Let's say we got total 3, yes, 3. And then you get the second equation, 6, 7, 5.2 equals 3. Now you can keep going. The third month, you pick this, and the same x, y. Let me add. And the 3.086 times, and they add the third number, that's 2.38. So on and so forth. You can write as dot product first if you want, but the best way, you can write into a matrix multiplication. The 6 by 2 matrix times 2 by 1, you get the 6 by 1 matrix. Well, you have 2 variables, you get the 6 equations. Is that right? Well, it's not right in your high school algebra, but it's right in our later application. You're going to see this we call it an overly determined problem. And in most statistics, we don't just observe 2 numbers, 2 months. We observe 6 here, sometimes 6 hundreds, but to try to get a relationship. Well, you can try to do those exercises. I think you got the idea how to multiply dot vectors as dot product, a matrix as a generalization of the concept of dot products. And the most important, interesting lesson you learned today, I think, I hope, you're going to connect the operation to the biology application, to look at the meaning of the multiplication. As an exercise, I would like you to write this into matrix form, and later on, we will not write the equations one by one. Most of the time, we write into a matrix times a vector equals another vector. And that's your homework. So see you next time. Thank you.